Welcome to the Land Tamer stream, live from the Land Tamer Studios in just outside of Orlando, Florida. And this, in fact, is a background today. We're looking at a shot from Cocoa Beach that I got off Flickr. Don't worry, it's Creative Commons license. So anyway, this is one of the closest beaches to where I live. And man, am I itching to go to the beach. You know, we've been having this cold weather. And I'm definitely ready for it to get warm again and head back out to the beach. But yeah, so we're doing multicast today, folks. And this time we have audio. At least I hope. I'm doing some testing over here. It looks like we have it. Let me see. Yeah, I believe we have audio. I did some other testing. For some reason, I'm not sure why, but in the last stream, I had no audio at all except for like the little intro video. Who knows? I think it might have been because the mic wasn't connected or something, but we're good now. I'm going to test now prior to every stream kickoff. There's a little series of buttons I hit in OBS, a shortcut key, and boom, I start streaming. And there's a little indicator that shows audio, but from now on, I'm going to do a audio check, do a recording first, and then go on stream. So there's a lot of prep that goes into streaming. It doesn't take up a tremendous amount of time. You know, the main focus here is me learning the CCIE. The stream is just kind of a sideshow. But, you know, it does take a little bit of preparation. But it puts me in the right mindset and helps me to grind. So here we are. We're going to talk about a couple things this morning on stream. One is CCNP is expiring in 4 days. Yeah, I made the decision a while back. You know, you get an email from Cisco and it says, "Hey, your cert's about to expire. Better do something fast. Act fast before you lose it." And you know, I made a decision a while back. I pondered this quite a bit, and it's not about the cash or the time. Well, really, it is about the time more than anything else. I mean, I'd basically have to take a day off, a vacation day, and I would have to book an exam, and it would probably be the T-shoot again, which to me, what's the point? You know, yes, it's taken me longer than 3 years to get this far in my CCIE studies. Part of that was moving, you know, family things. So yeah, I'm not ready to take the written yet. I'll be taking it in about, hopefully in 5 months, and hopefully passing. But what's the point at this stage? I have so much momentum in going for the towards my CCIE written. I don't want to have to stop. I didn't want to have to stop and take extra time to plan for the T-shoot lab. I'm not ready to plan for the T-shoot for the CCIE lab exam. That's the next time I'll plan for troubleshooting. And until then, I just don't want to stop. I want to keep going. And, it's not where I work currently, it's not a big deal. Granted, if I was trying to get into a VAR right now, it would be a big deal. And yes, I would do it. But, right now it's not. So I made the conscientious decision. It's not like I'm panicking the last minute because I didn't realize it was so close. I've been watching this and thinking about this for a couple of months, and I decided to just let it go. So, I know others who would condemn me and say, why? Why do you let it go? What if you don't? No, my mindset is I'm so determined to get the CCIE routing switching, however long it takes, that to me right now the CCNP is just a sideshow. So granted, I feel confident I could go right now, take the CCNP T-shoot and pass it. I have no qualms about that, about being able to do that. But again, it's just time is so precious and so valuable that any investment of time, whether it's a half day and a few days of preparation, is too valuable to lose towards getting the CCIE, right? That's my attitude right now. So anyway, that's my take on that. That's that vlog topic for the day. Sorry again about the audio of the last stream. Someone commented on YouTube, because after I stream it on Twitch, I upload it to YouTube, and someone commented like, hey man, there was no audio for the whole video, and I'm like, oh my gosh. So I deleted the video off YouTube. I deleted off Twitch. The audio appears to be fixed, so we're just gonna carry on. Thanks again, whoever it was that helped me out with that. I appreciate it. Otherwise, I probably would not have known. And there's nothing more disappointing to click on a video on YouTube or Twitch and there's no audio. You're like, stupid channel. So anyway, that should be fixed. A couple of meat chunks. One is this came out of someone in Router Gods mentioned this because I kind of said, hey, I'm starting multicast. Here we go. And someone's like, hey, you need to watch this video. And this is a VOD session from Cisco Live, and it's Denise Fishburne, the famous fish. And man, this really helped me. And I have to say, with videos, and that's where I'm at right now, right? I'm watching a lot of videos on Multicast. The INE videos were good, but it just didn't really click the first couple of videos for INE. I went back and watched this, and it kind of clicked for me. Like, wow, okay. That makes a lot of sense. I haven't even finished this video. Just got into kind of the introduction. Her video is on troubleshooting multicast. But in the beginning, she talks about, gives an overview, has some nice graphics, images. And it's like, okay, wow, it kind of clicked. And she even talks about, it clicking for you. So once that happened, I went back and rewatched part of an INE video and another INE video, and now those videos look really good. Now that the concept has sort of clicked for me, the things that Brian is saying, those videos make a lot of sense. Whereas before it was kind of iffy. So I highly recommend this link. And then this is a really interesting link. It has to do with using iBGP through an MPLS VPN cloud from this blogger, tgregory.org. Really good blog, interesting concept. Thanks to Tony for sharing that. It was a good read. Recommend that. Now let's get into whip cracking. So these are labs. I wanted to go back and do the dense mode lab that I did Thursday night. One, because the video had no audio. I'm not going to redo the MTU stuff. That was unfortunately lost, but it's okay. That was kind of a sideshow as well. But we're going to redo the dense mode. Now that I've had sort of an aha moment about how this stuff works, how these trees work. Let me just correlate what I've done on the videos so far. So on the videos, if you do INE, this will be helpful to you. If you're not, it makes no difference. But let me see if I can pull up where I see So on the videos, I did the overview video. In dense mode, sparse mode, I finished these three. I finished this one right before coming on stream this morning. But the dense mode and the lab, I got through, but I had to look at the key, one. And I missed the IGMP part, big important part. So I just didn't feel like I did that lab thoroughly enough to where now when I go back and do it, I should really understand it. And that's the key, right? We're learning. So let's go ahead and get ready for that. And I'm going to pull up the requirements. I've already got the initial .multicast topology loaded from Enviral. I've got virals up and running. And let's do the requirements here. I'm enjoying multicast so far. Of course, I'm a nerd. I'm the nerd who always sat in front of class in the front row and asked questions. I've just always been that nerd. But I felt a little intimidated prior to really knowing much about multicast. I've seen questions here and there in the Boson exam. Been a little intimidated by it, but now that I'm learning it, I'm like, oh, this is really cool technology. I like this protocol. Which is usually how it goes with all the protocols. Like when I did MPLS, and BGP, VPN before, it was the same thing. I felt very intimidated, but once I started looking, oh, that's really cool. So it's happening to me too with multicast, which is fine. But let's pull up our lab requirements. Standard disclaimer here, guys. This is not a lab I designed. So I'm just working through the INE workbook. I'm not going to show you the workbook. I'm just going to kind of notate some of the requirements here. Paraphrase some of them. But if you want to do this lab yourself, definitely check out the link in the channel in the INE workbook. I think it's $2.99 before discounts. So, but this is we're going to go back to PIM Dense mode. And yeah, it says basically enable PIM on the path between R6 and R10. Don't enable on DMVPN. And what else? To test, we want R10's 1.10 interface to join 224.10.10.10. And then make sure R6 can ping this group. So yeah, much different concept. Just it's interesting to learn dense, then learn sparse, then go back and do dense, because there's no without a rendezvous point. You know, we're just basically blasting. Let's pull this topology, by the way. So yeah, we are essentially just blasting multicast and assuming there's an implicit join, right? That's the difference between dense and sparse. So we're going to enable PIM on all along this path here through to 10, yeah. And even here, right? Actually, you know, do we need to do that? Hold on. So this is going to be this interface will be joining the group, so it will need to send I'm wondering if this interface has to be PIM enabled. I think it does. I'm going to enable it just in case. So let's try to draw this again. Yeah, basically all of this. So that will be our. And this is the other thing I didn't realize before I even kicked off the lab, and I did the dense lab too early. I wasn't really ready, but you know, it's interesting how the protocol is separated, PIM and IGMP. But very important and different sort of trees, right? Or parts of the tree. So we're going to have all these are going to be PIM enabled. We're not going to enable it on this here on the DMVPN. And then we're going to have router 1.10 is going to request a join. Okay, we want to make sure our router 6 can then ping all along the tree. So I think what's going to happen is we're going to enable PIM. And then at that case, we don't really have a sender yet, right? So we'll have a star comma G for, what is it, the all multicast, all PIM routers group, 224.0.0.13. So if I do a show IP multicast, show IP PIM, I think I'll see star comma G all along here in 224.0.0.13 before I send any traffic, right? That's my hypothesis. Put my hypothesis here. So we should see star comma G, star comma 240013 on all enabled interfaces. So any sender, right? Because this is prior to sending any traffic. All we're doing is going to establish, so when we enable PIM, the PIM protocol will send a discovery on that interface to 2240013. And I think at that point we will get a star comma G in the PIM, in the mroute database. But no prunes yet, right? Well, let's see what that looks like. Because again, after doing sparse mode, I had to rethink dense. Okay, well, how does that work then in dense? Again, I need to see that. So that's another reason I'm doing this lab. But let's put this up. I believe I already know the commands. So let's just do our configurations here. Router 6. We'll put them in the order that they are in the past, starting at quote unquote the top. So we'll do. Oh, do I have my chat up? Yeah, chat is up. Yeah, anybody wants to chat, join the chat. Feel free to hang out. I did send a tweet this morning in case anybody wants to play along. And let's see, we're going to do a router 6 interface GI01-146. Actually, the first thing we need to do is IP multicast routing. And then interface GI0146, IP PIM multicast. Is that the command? Let's boot up our routers. Still learning these commands, guys. So router 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, router 1. So let's go. Is router 1 in here? Yeah, he'll be in here. So theoretically, it shouldn't take too long, right? And a router 1, no, he's not really along the path. But router 4 is. And same GI0146, it's GI0145. But let me make sure I have this command right. 1, 2, 3, 4, 5, 6. And let's see here. Let's just pop this in. IP PIM. Oh, dense mode or sparse mode, right? Dense mode. Yeah. IP PIM dense mode. DR change from neighbor, any neighbor, to on interesting. Okay. IP PIM dense. So we're going to do this on all the routers, right? In the path, router 4, router 5. And he's going to be GI0145 and GI0158. And then router 8 is going to be GI0158 and 108. And router 10 will be 108 and what did it say here? 110. We may try it without first. I need to think this through and make sure. I think I need it. I really do sincerely think I need it. Okay, router 6, router 4. That's the configuration there. Also, I want to set up a capture because I want to see, what I really want to see is in transit what this looks like. I want to see messages coming to and from the sender and the receiver. So last time I initiated a capture at the receiver, And there's a lot of stuff I missed, like prunes and things like that. I don't know if I have any prunes here. Will we have any prunes here? That's the message I missed that I did not get. Yeah, we won't have any prunes here that I'm aware of. We'll see that probably in, that's true, let's probably see that more in sparse mode. But anyway, I wanna do a capture here on router 4. And I'm trying to think, what would we, I'm not gonna do this on this lab, but on the next lab, I wanna do a selective capture filter. Because I'm learning you need ICMP to see the complete picture. You need PIM and you need IGMP. I think that's it, but we're learning. So we're going to capture along router 4. But let's go ahead and enable it. And yeah, because see, I want to see it come up. Net viral 008. And then router 5. One thing I'm not doing enough, guys and gals, on these routers, on these labs, is I'm not doing debugs enough. I noticed that in the INE video that, you know, he frequently turns on, for the purpose of education, of course, but frequently turns on debugs, which we should be doing more of. You know what, that may happen. There is actually a troubleshooting lab, which I like. So the way the labs are set up, we've got PIM Dense mode, PIM Sparse mode, and then PIM RPF troubleshooting, which I think is a great idea. I wish they did more of those. All right, we got the wrong port here. Let's close that. Telnet. Okay, so let me just kind of do a little bit of validation here. We'll go to the middle, right? Router 5. So if I do show IP PIM neighbor, I should have 2. And we are doing, it says version 2. And priority, I don't know much about this. I'm not too worried about this right now. State refresh capable, P proxy capable, G GNID capable. Don't know what that means, but I'm sure we'll learn later. But we see the interface. We see the state here, and the expiration is 1.5 minutes. Or I guess maybe it starts at 2 minutes. But let's do show mcast. Let's see, what is the command? Show IP PIM. No, show IP mroute. Yeah. Okay, so 224.0.140. What is that? So incoming interface is null. And outgoing, because we have no source yet, right? So this is star comma G 224.0.140. I believe this is that randomly generated? We just turned on PIM. We've had no multicast traffic, source traffic. So what is this group? I want to do a search on this. No, I don't want to Google. Deny. Multicast group 220.140. Come on, load. Is a reserved multi for Cisco Discovery. Okay. I need to, guys, I have a document out here on the Google Drive for special multicast addresses, I think. And there was someone actually, Rav Perrine, I think is his name. Praveen. Rai Praveen had talked about, hey, does anybody want a new cheat sheet? And I was like, well, man, multicast would be great. Why don't you do one for multicast? And I don't see it here. I think I have it on the LAN tamer. Guys, you know, when I started out the stream, I did not have a Google Drive. All I had was this LAN tamer folder on my desktop. I've slowly tried to move things in there, but as you can see, well, I called it what I call it, layer 2 addresses. No, these are really okay, we're going to change this. So we're going to do our own sort of pseudo cheat sheet, right? We need to start it now. Should we do a folder? Yes, we're going to do a folder because even though it's one document at this point, I have other cheat sheets, guys. I just have not shared them in here. So let's do a new folder. Cheat sheets. If you wonder why I use hyphens so much, it's because I've been a long-time Linux user. And if you use Linux, you know why you use hyphens and not spaces. We're going to do a Google Sheet here. Yeah. And we're just going to call it Multicast. Multicast addresses. So you got to start somewhere, right? We're going to divide them into layer 2, because that's how this all started. Layer 3. Specifically, these are going to be layer 2 Ethernet. We're going to say, let's see here, address. What are our fields? Address. Type. We got into that a little bit. Subtype. And use. I hear my PC chugging. And I know things seem to be performing just fine in our stats. We've got no lag really. So I'm just going to shut these switches down. In fact, I do not need, in this lab, I don't need router 2. And what else can we get rid of here? Oh, we got messages. Okay, just responding on I see you, Tony E. Oh, thank you. I need to change my Twitch BRF aware DMVPN. That's weird. Oh, thank you, Tony. So we got a little situation here, guys. Let me, sorry. Need to fix this really quick. When I tweeted this out, okay, thanks. And he's doing multicast tunneling. See what I do? Oftentimes I come in here and I update this, but I don't click update. I always forget to do that, so. So yeah, Tony's gonna do some multicast tunneling. Cool stuff. Ooh, I know I'm not ready for that. That sounds pretty intense. All right, so we're just gonna paste these in here. We fixed the video title. And this is PVST plus. Surely I could, well, this is in Notepad, so it's not gonna, what's in text edit. Okay, that. I need to remember these, folks, because you know how it is. When you get ready for an exam, like what they do with HSRP, this MAC address, blah, 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 what does it mean? We need to know some of these slow protocols. I love that, slow protocols. They didn't get always picked out in the schoolyard because they were the slow protocols, poor protocols. I guess it's better to be a slow protocol than not a protocol at all. Okay, and then the subtype here for slow protocols was this. 8809. Okay, we got that. And subtype 01. Okay. Now let's see. We can close that out. Probably get rid of that. We'll do that later. So this now is 224.0140. I'm going to notate that later to 40140. And this is, as is mentioned, RP Discovery. Cisco RP Discovery. Rendezvous point. Cisco RP Discovery. Now, does each vendor have their own? Let's go to Wikipedia, man, because I actually looked at this the other day. And multicast addresses. Wikipedia.org. Some people say wiki, I say wicca, whatever. So, okay, this is the range. And then there should glop. Yeah, we talked about that. Okay, so this 13 is PIM v2. That's what that is. So here's a question. When this discovery happens, what address, when PIM is enabled on the interface, what address is it using to do that discovery? Is it 40 or is it 13? Let's see. Let's look at the capture. Oh, come on. I thought I did the capture here. It says it was successfully created. Oh, because I have node selected. That's right. That's why. Yeah. So let's take a look at this. I never did. I got distracted. I never did disable those nodes. Let's do the switches now in router 2. That's why. Okay, so let's take a look because I want to understand each of these entries here. I want to understand everything that I'm seeing in this multicast table. Okay, so let's do PIM. That's what I thought. So it's sent on 13. Yeah, 224.0.13, and the protocol type is 103, right? And PIM version 2, which is interesting because what it does is there's a DR priority. That's probably initial. Okay. And we'll delete this because it's going to get cluttered later if we don't. Okay, interesting. So they're sent here, but then we get a star comma G for 224.0.140. Okay, so when we talk about the order of operations of multicast, it would make sense that you do your discovery with one address range, but then you listen for an RP discovery 220.140, which we'll see in the sparse mode lab. Okay, well, this makes sense to me now. But it says the incoming interface is null because we have no incoming traffic yet. But every interface it's configured on is configured as an outgoing. Let's look at router 6. Show IP MCAST or MRoute. Got to get these terminologies correct. Okay, inner is null, outgoing is a single. All right, everything so far is making perfect sense. So All right, these are my little monitoring computer. 3 monitors and 1 computer wasn't enough. Now I've got 4 monitors and 2 computers running the stream. So anyway, that clears that up. Moving right along to our next phase here. I think we understand what's going on. So really what this is 40. I had the wrong, and it's 1.40, right? By the way, this is 224.0.0.13. PIM v2 neighbor discovery. Okay, good. All right, moving this off to the side. Back to our lab here. All right, so we've got a tree set up. We want to see, yeah, we don't have any RPF yet, right? How do we do that? Show, what's the command to show RPF information? Show IP RPF? Okay. IP name or address of multicast. What if we did 224.0.1? Will we see anything yet here on this? Show IP en route. Show IP RPF 224.0.1. Oh, must be a unicast. Yeah, that makes sense. That makes it. Okay. Well, we tried it. We played with it. We satisfied our curiosity. Now we can move on. All right, so now we need to set up a receiver. And that's going to be router 10's. That's going to be router 10's interface JAS0110. So what we do is we do IP IGMP join 224.10.10.10. So let's see how this changes the landscape here. What it should do is it should now advertise as an IGMP message. I'm not sure how that's going to change the table though. Show IP IGMP groups. Okay, so now we have a group address. Oh, we could add this before. We're a member of this group, right? A listener. Last reporter. Okay, so in IGMP, we're seeing the output of this new IGMP group address, which interface is a member, and the uptime, when it expires, and last reported by myself. Let's go up the tree. And the next router is router 5. First of all, does that change the routing table? It does not. Show IP IGMP. Okay, so interesting. This is the tunnel. This was talked about in the video. Essentially, when you for your sender and for your source and destination, your sender and receiver, to overcome some sort of shortcoming in the protocol with the DR selection. It's a relatively new feature that it introduced, iOS has introduced these tunnels. So we have a new tunnel interface, and we have a new IGMP group membership. We still have no sender though, right? So that's why I'm assuming we don't see it yet in the routing table. Until we send a packet. Let's go back up the show IP RPF. (224.10.10.10). Okay, yeah. This would be the RPF to the unicast address of the sender, really, right? Reverse path forwarding. So There's no RPF for a receiver, I take it. The receiver is in the IGMP table. Okay. So now what we need to do is send the traffic. We need to generate some traffic so we have a sender on the network. And we're getting replies. So now we should have a complete tree, a shortest path tree. And again, a shortest path tree is S comma G, right? So sweet, good. This is good. So what I want to do is walk the tree to be sure I understand. So I want to see the inbound and outbound interfaces for this group, 224.10.10.10. And I want to follow that all the way down. And then I want to do an RPF path, a reverse path verification all the way the other way. So let's do show IP PIM. PIM, what am I looking for here? Show IP PIM interface. We haven't done that yet. Version 2, mode is dense. Good. Show IP M route. That's interesting. I would expect to see. Well, that's true. The sender is not going to have a multicast route here. So from a sender's perspective, I guess, when I do a ping, that's interesting that it does not create an entry in the multicast routing table. Is it mfib? Show mfib state. Interesting. So I guess 6 just knows that it's just going to forward all multicast traffic out of this interface. Interesting. What if it's enabled this way too? Will that change the destination? Let's do it. Yeah, it's going to send the traffic out, but this is stopped. No, it's only going to, because it has no neighbor. Okay. So I guess anywhere it has neighbors, it's just going to blast the multicast traffic. Okay, well now we know how that works. So let's go to router 4, is it? Yeah, 4 is where we're doing the captures. Show IP M route. Okay. Good. So now we have, it's interesting now, I think this is, of course, what we're going to have in dense mode is we're going to have S comma G or star comma G for this. Incoming interface null. Outgoing is these interfaces. So it could forward it out back to itself. But again, this is just star comma G. But on S comma G, we have this specific source. And here's where we have our RPF information start to populate, right? So we have incoming interface is here. outgoing interface is there. Makes sense. This table makes a lot more sense now to me. So if I do show IP RPF, then we have to have the host name, right? Group base. So the host name will be, yeah, RPF interface, RPF neighbor directly connected, multicast doing distance per lookups across tables. Gotcha. Okay. All right, that makes perfect sense. Do we have anything in the IGMP table here? We do. And it says group address 224.0140. Yeah, but that's just the RP listener. Okay. Now let's go to router 5. Interesting. Did it time out? Oh, it did time out. That was quick. Let's continue to send packets here. Well, I guess that's good. That's efficient. You don't want to maintain state. We did kind of get distracted there for a while. Let's do a repeat of 500. There it is. Okay. So same thing, 224.151.146.6, incoming interface, RPF neighbor, outgoing interface, and down the line, right? Until we get to router 10, show IP mroute. Okay, same thing. Okay. Show IP IGMP groups. Okay. These report. So we should have, that's what I meant to check up here. Show IP IGMP groups. Yeah. Well, we don't have IGMP here. Is that a timing thing? Let's look at router 8. Last reporter. This expires in 2 minutes. Okay, so that part is a little unclear to me still. Does it remove the IGMP entry? I know it had to receive an IGMP. Or maybe that's more important in sparse mode. I'm not sure. Okay, but we've got a tree. Our pings are working. Everything looks good. We did not have to look at the lab answer key this time. We got some good packet captures, so I think I'm probably going to leave this here. Let's just take a look at the lab key again and make sure that we're good to go. IP multicast routing, yep. Config looks good. And the verification, show IP PIM neighbor, interface, ping, show IP mroute, yep. Yeah, RPF, show IP RPF. Yep, we did that. Okay, good. Lab done. All right, now let's move on to sparse mode. Oh wait, the next lab here is multicast RPF failure. Okay, good deal. So let's do requirements on this. Let's stop our capture. Nodes, want to select none so that we can stop the capture. And we're going to download it. Before we start this other lab, I do want to take a look and make sure I understand everything that's happening in this traffic, in this packet capture. Here on router 4. So let's just do, what packets do we need? We need PIM or IGMP or ICMP. Okay, good, good. So it's interesting, we've got these IGMP report groups happening, and this is generic, just if you are speaking multicast, right? Which is interesting. So a number of different multicast addresses are used to establish and maintain PIM neighborships, right? Because we've got here 224, we've got router 4 sending a packet to 224.0.140. So we kind of establish a tree, don't we? On this 224.0.140, which is our Cisco RP Discovery address, right? We sort of get a tree going here. We've got IGMP v2 messages going out. Then we have a query. This is interesting. What is this query? We have an IGMP membership query of 0. And then I'm assuming we get a response. All these routers are saying, okay, who are you a membership of? We get a membership query, send me a report of all your IGMP memberships. And then we have these routers reporting back out. So, and these appear to be periodic as well. So just kind of some back-end maintenance that goes on, right? Okay, then we've got 2 pings that happen in this lab. What I want to see is an IGMP for router 10. And there it is. So this should reach router 4's interface. And we get a membership report after I added that configuration. Where does it first start? 224. Right here. Multicast address 240.10. Yep, source and destination. Membership, your basic IGMP membership report, right? Look at me. I want to talk. I want to talk right now. Okay. Screen cap that. What else we got going on here? Membership query, membership report to the group. So that's periodic. At some point here, we're going to start sending our pings. So we got the request, we got the reply coming back. It's a little more maintenance. We got these hellos that are still going out from time to time. I wonder what those timers are. I'm sure we'll get into that into one of these labs here. Okay, good stuff. I may say that I saved the capture already, folks, in the... This is a cleaner capture, so we'll probably get rid of the other one. Yeah, let's save this. And we're going to call this is 2018. Actually, multicast, we'll say PIM Dense mode. And time is 10:04, and this is from router 4, R4. PCAP. Yep, and we're going to take this capture out because if anyone comes back and look at this, first of all, the video is gone, the original video. Second of all, this was captured at the receiver. We want to capture it along the path. You get a lot more of the story. Okay, we're going to put this here. Good. Okay, little maintenance. And I think we are ready, now that we looked at our capture, to do this next lab, which is where'd you go, lab? Where'd you go? Yep. So multicast RPF failure. All right, so for this we want to do, let's see, the requirements are pretty much the same. Same PIM path. Don't enable PIM on GI0 145 between router 4 and router 5. Instead, enable on tunnel 10 connection between router 1 and router 5. Ah, so that tunnel is not what I thought. Show run interface T10. Oh, they stuck a tunnel. I'm not used to this being here, but he stuck another little tunnel in here to kind of throw us off. Okay. I thought that was the dynamic tunnel that forms as part of, but that must only be in, that's right, that's only applicable in sparse mode because of the rendezvous point, so I misspoke. This is a tunnel that is built into the lab manually. And we're going to do the same test. Okay. All right, let me get a little water. So the point of this, I take it, is that we are going to have unicast. I think I know what's going to happen. What we're going to do is we're going to have a tunnel between router 1. Oh, so we're going to turn this on. Don't enable PIM, but instead enable on the tunnel between router 1 and 5. Okay, so multicast will not be enabled here. On this physical interface, I see what they're trying to do. So they're going to have a tunnel interface here with multicast enabled. But multicast is not going to be, we need to change colors here, we need to change colors here. And then we needed some red. We're going to demonstrate a RPF failure. Excuse me there, I had to sneeze. Okay, so will the packets reach? I think the ping is going to fail. I believe the ping is going to fail because, okay, it'll be blasted out here, blasted out. It won't be blasted this way. Enable PIM Dense mode on the path between router 6 and router 10. So we won't form an adjacency here. Yeah, I don't know how this is going to work at all. Anyway, all right. I don't think he intends for the ping to work. Make sure that R6 can ping this multicast group. I mean, I know how to fix it. All right, so let's follow the instructions. So we're going to go back to router 4. And we're going to say no IPM dense here. And on router 5, no IPM dense here. And instead enable on the T10 connection between router 1 and router 5. So router 1. We're going to say interface T10. And we're going to do the same on router 5. And it's not going to work, and then we will know how to fix it. So let's go to router 1. And router 4. Okay, down. Good. That's what we want. And router 5. Interesting, he already had a neighbor up. But I had not enabled it on that interface unless it was already. Okay. All right, so I think what it wants us to do here is send the traffic, which will fail. And then we have to troubleshoot why it's failing. So what we need to do is, I think, and I believe I remember this from a video, it was stated that it's easier sometimes to just troubleshoot. If you're troubleshooting a tree problem, is to start with the RPF check. Start with the RPF check. By the way, let's make sure Nightbot is up and running. One hour, 3 minutes, 6 seconds. Well, I need to change that Nightbot command. Because I just want the... Anyway, we'll do that off. So if I know that router 10 is a receiver, let's do show IP mroute. Okay, yeah, so as we can see here, we should know we already have a problem. Because if we know that the sender has already generated traffic, but we have not received anything, we should have an S, G entry here, but we don't. Incoming interface, even for this, is null. Without a lot of information, though, here, I'm not sure how you would be able to troubleshoot. Yeah, where would you start troubleshooting this? I mean, I know what the issue is, but I want to be able to objectively know how to troubleshoot it. So I guess I would do first, try PIM. I would do that first. So I know that I can go to router 4. Show IP PIM. We get a loop here, right? 464646. Obviously, we have an issue there. So I think all we have to do is enable it here on router 1. And let's see if that works. Oh, we did enable it on the tunnel, but right, we did not enable it on the, we have no path to the sender. IP PIM Dense. Okay, now our neighbor 6 is up and 4 is up. So now let's try to send our traffic again. Okay, this is where I guess the lab is supposed to get interesting. So, all right, so we know we have a path. Granted, it's not a physical path. It's over a tunnel, a logical interface. So now let's do the RPF check. First, we'll do an MRoute. Okay, we still don't have, so we need to go down the path, right? We need to do RPF check down the path towards the source. Let's go to router 1. So we have RPF. Okay, so here we have an S comma G. Good. And we have an RPF neighbor. And we can do the RPF check, right? Or should we do it? Should we do it going this way or should we do it going this way? I think we should go this way. Yeah. Yeah, let's do it this way and see where the RPF failure happens. That seems to be a little more logical. So we'll go to router 8 next. Show IP MRoute. Okay, we see we have no route there. Then we go to router 5. Okay. We have it, but the RPF is to neighbor is any. So that almost tells us that the RPF check has failed because it says null. Our RPF check has failed. And let's see why. Show IP route. Ah, okay. That makes sense. There you have it. So this is saying right now that my path to the sender is through an interface that is not speaking multicast. Show IP RPF and 151.046.6. Yeah, look at that. Nice. So that's cool. We've been able to sort of emulate by way of this. I like it. Cool lab. How do we fix this? Well, we need to turn multicast back on, right? If we do that, then let's see if that fixes it. IP PIM Dense and actually let's do this. Debug IP RPF. Can you do that? Debug IP PIM. Debug IP PIM. We're still sending traffic. Let's try to send traffic. See if we see that failure here. Building graph message. We're still pinging. So it could be that does this not even reach router 5? It should be reaching it over the tunnel. Yeah, we should have the entry, and we do. Yeah, so we're not getting any debug. Yeah, I want to see the debug for the RPF entry. Maybe it'll show it in the lab. All right, so all we need to do to fix this, of course, interface GI 0145 IP PIM Dense. I'm assuming. Assert. Yeah, there's the assert message. We win, yay! We lose. There we go. DR change from neighbor to on gigabit. Okay. Send join prune. The debug language here is so funny to me. Sounds like someone who's very excited about multicast developed these. Check DR to interface. It came up. Okay, are we getting pings now? Yes, we are. Okay. I like this lab. Cool little lab. Simple, but very effective, I think. Okay. All right, what do we got now, guys? Does that, I think that does it. Let's check the lab answer key. Yep, incoming interface null, RPF neighbor is 0000. Okay, so here's how you debug it, I guess. Now this is cool. I like this. So let's do that. Let's do undebug all. Debug IP mfib. Let me just do mfib. Oh, I have to select something here. Pack. mfib IPv4 pack debug enable for default IPv4 table. Okay, so now if I do interface GI 0145, no IP PIM dense. We should start to see these failures, right? We're still pinging. Acceptance check failed. Yeah. Packet is marked as not to be forwarded by mfib. Punting. A little different from what I'm seeing there, but now apply the static multicast route on R5. Oh, this is interesting. So what we could do is this. IP multicast route default. Tunnel 10. So how does that change our routing table? Show IP mroute. Oh, here we go. Look, it did how do we see the default route though? Static. Okay. But I don't see sort of the equivalent here of like a it's really unusual. RPF neighbor though. So in other words, if I need to get to this source for multicast traffic, I'm going to take that interface. Interesting. And is this working? Yes, it's working now. Okay, I didn't think about that. Now show the state. Okay, so it does point out when we use a default route, it creates a problem here, right? Because what if I'm a sender? What if I have traffic going the other way? Like show IP RPF. This is going to force it to go out tunnel 10, and that's not the way it needs to go. So the better option would be no IP route. It would be IP route 5.146.6. And that would be the more appropriate solution in that situation, right? Yeah, we had some failures. Now they're working. Good stuff. Nice lab. I enjoyed that lab. Okay, now we're going to move on to sparse mode. And same lab configuration, but we need to undo our configuration. I mean, it's same topology, but we need to adjust our configuration now. So, guys, we'll take a little nature break, grab a snack. I'll be right back, and we'll keep rocking here. I think I have a good screen for this. And we're back. Had to get something to eat, man. I'm hungry. I already ate, but feels hungry. All right, so now we're getting to the PIM Sparse mode. And want to remove the configuration we had in place, which is nice. We've done everything in Notepad, so all we have to do is come back and do no IP PIM Sparse dense mode on here. So we'll go to router 1, remove that, just do a little cleanup. And this is good because we're going to use the same configuration when we go to sparse mode effectively. And are we still capturing? No, okay. All right, and then, yeah, router 4, no PIM Dense. We're going to try to work out a Notepad here so we, get good practice with that. It's going to be real important. Notepad's your friend in the lab, right? That's what they say. We're going to take it off this tunnel. They snuck that tunnel in on us. I didn't even know that was there. Okay, and then router 8. Also remove that here. I'm curious. I need to look back and see what did we have to enable PIM on router 10's 1.10 interface. I meant to check that. We did. Okay, I thought so. I was trying to figure out a way of not having to do that, but yeah, we need it. So we had to have that here on router 10's GL110. So we're going to take this out, and we're going to take this out. All right. So we configure router 5. Let's go back and do router 8. Okay, and then router 10. Yeah, I like that troubleshooting lab. I hope they do more of those. They're definitely not enough. You know, we do mostly just configuration in the INE workbook. I understand at the end there's some big labs where I'm sure they involve troubleshooting. I've heard they're rough, so I'm sure they'll make up for it. But I really like, as I'm learning the concept, to see where something can go wrong right away. And if I had a bunch of money and were to buy INE and buy the company, one thing I'd have them do, come back and do is introduce more of those little troubleshooting labs or problem labs along the way. Anyway, they're great though. Don't get me wrong. It's a great workbook. All right, PIM Sparse mode. We're going to enable on the Ethernet path between router 6 and router 10. Same. Okay, interesting. We're going to configure R5's loopback as the RP. And same thing, R10 will join group 224.10.10.10 on GI0110 interface. Good. All right, so obviously it's going to be a little different. All these interfaces, the main thing is they're going to be IP PIM Sparse, IP PIM Sparse. Let's do this. IP PIM Sparse mode. And then what we're going to do as well is on router 10, we are going to do an same IP IGMP join this group. And the way that we designate, now this, I've seen it on the video, folks, but I need to let's remove this. Let's go ahead and get a drawing right? So router 5's loopback is going to be the rendezvous point here. This is going to be our RP. Okay. Yeah, so what we're going to do is we're going to look up the configuration for this because this is new to me. And let me open up Safari here. Let's go docs. Configuration. Oops, not release notes. Nope. Configuration guide. I had a lot of trouble on Thursday night when I was trying to find documentation for dense mode. I can understand maybe it's under, it's kind of, it's obsolete. I understand. And not being just super easy to find, but man, I had trouble. PIM allow, RP, implementing multicast stub routing. Oh my gosh. Tunneling. Oh man. A lot of good stuff here. Okay, PIM IPv6. All right, should be under here. Basic IP multicast, configuration examples for IP multicast. Here we go. Single static rendezvous point is what we want. So this is under the interface level? Sparse mode with a single static rendezvous point. The following sets PM for all multicast groups to find all groups to operate in sparse mode. Now, do I install this? The following example says the RPM. Oh, okay. IP PIM RP address. All right. Maybe that's all we need. Looks like we need it on each interface, though. So let's try this on router 6. Router 1's fine. IP PIM RP address would be here. Ooh, we don't want tunnel 10. No. 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 Interface T10, no IP PIM sparse. Okay. Router 6, we want this. And this can go away. Go away, router 1. We don't need you. Okay, so is that all we do? Don't we have to put something on router 5? You know what? Let's go to packetlife.net. Packetlife.net to the rescue. Jeremy Stretch's page. I just want, sometimes it's just a little cheat sheet. You can just verify your configuration. I thought he had, does he have multicast? Yeah. IPv4 multicast. The IGP PIM configuration. RP configuration manual. Okay, IP PIM RP address. Okay. Looks like that's all we need. We're going to try that anyway. That's what the documentation is saying. So what we'll do here is on everybody, does that include router 5? I guess it does. And the question is too, do you have to put it on each in interface mode? So let's go to router 6 and try this before we go crazy in Notepad here. Okay, we do. And this is the tunnel I was talking about. This is the tunnel I was talking about earlier. Okay, so we want to change. We want to add this here and here. What did I just do? All right, I don't know what just happened there. I have no idea what just happened there. Router 4. Copy. Paste. There you go. That's all I wanted. Okay, now if you PIM. Okay. So I'm going to do that on router 5 as well. I guess we do need to enable it on the tunnel interface. Or the loopback interface. IP PIM. And why are we doing dense? I thought I fixed that. You're just not cooperating this morning. IP PIM Dense. Let's do. Yeah, replace all. Okay. Back to router. Okay, router 4. What are you doing here? IP PIM Sparse. What? Hello? IP PIM Sparse. IP PIM Sparse mode. I don't know how all that got so sloppy, but it did. Anyway. IP PIM. Okay, there we go. IP PIM Sparse, IP PIM RP address. And do I have to put that on the tunnel, the loopback itself? We want no IP PIM. Let's clean this up, man. Okay, good. All right, IP multi-router 8, IP sparse mode. We need our PIM address. That is one thing they're commenting on in the videos, is that there's no single configuration sort of mode for multicast. I mean, you have to do a lot of configuration at the interface level. So, all right, router 6. We put that configuration in there. We're going to do it just to be thorough. And we're going to do it on router 4. Okay, liked it. And router 5. This should be interesting. Cannot enter topology static route. Oh, we have a static route here. Yes, I will take that out. Show run, excuse me, route. Yeah, we have a static multicast route here. Thank you. Okay, that's a problem with going into from one lab to the other. All right, router 8. Good. And router 10. An IP IGMP join. Okay, what did it not like there? Interface jet 0110, IP IGMP, join group, IGMP join. What didn't it, what if I just type join? 224.10.10.10. What did you not like about that before? So when I did IP PIM RP address, it knocked me, oh, that's a global. Show run section multicast, or PIM. That makes sense. Okay. All right, so just checking sound here. Yep, we got sound. All right. That's why I typed this and it dropped out of interface configuration level, interface level. And that makes more sense to me. Okay. So it doesn't work. Let's go right to the end. 224.10.10.10. It does. Awesome. But we should be able to look at a routing table here, and we're going to see now. Actually, you know what? It's not really going to look much different because our path is the same, whether it's dense or sparse. Right? There's no like path selection here. It's a one-way street. Well, it's a two-way street with no alternate routes, right? So I'm thinking that the multicast routing table is going to look pretty much the same. Let's see. Show IP en route. Okay, no, this does look a little different. Yeah, now what we're seeing is we've got more entries in here. 67.6. Why is that? Is that enabled on this interface? It shouldn't be. Let me check. I think I turned that on, yeah. Again, this is just cleanup, folks. When I was playing around, yeah. It's dense mode. Apparently it'll let you configure different modes for different interfaces. Yeah, so that was really clear IP en route star. And let's do our ping. Show IP en route. Okay, so now, yeah, this looks the same. Except we now have, no? Okay, star comma G. I don't think this was on router 6 before. Or maybe we didn't look, but anyway, it's null. Outgoing null, right? That's what we expect. So let's continue. We're walking down the path, right? We're walking the tree. So let's go to 6 to 4. Just see if we see anything different with the routing table. Obviously, the configuration is different. And we're going to want to do a capture on this too. But show IP M route. Yeah, that's garbage left over. Clear IP. That's fine. This looks the same as of right now. Yeah, everything looks the same. Show IP M route. Yep. Obviously, if we do a show IP PIM neighbors, we're going to see that it is in, we should see a different mode. Version 2, DRSPG. That's the same. Show IP PIM. How do we see the mode? Interface, right? Yeah, mode S, sparse. I believe that's what that is. Okay, so now, yeah, he has 0 neighbors. DR. How do we see the rendezvous point? PIM. RP. Yeah, that's what I'm looking for. Okay, here we go. Nice. Next, RP reachable never. Okay, let's go back. Let me back up a little bit. I want to see this on router 4. Show IP PIM RP. And there it is, 151.55. Can we show anything else? Mapping. Okay, it is static mapping. That's interesting. We do see that. And it's basically for anything. The question mark is DNS, I was told. If you do resolve DNS, then you actually see the DNS name here. Okay, cool, cool. And of course, we know that the process is a lot different with sparse mode, which I'm sure we will see in bigger labs coming up. Show IP M route. Yep, that's what we expect. Same on router 8. And it may have expired. Probably has. Boy, it does not stay up long. Which I'm sure is really what you want. You want it to be efficient. You don't want to waste state tracking. There it is. We have the RPF neighbor, which is correct. And then show IP PIM neighbors. Show IP M route. Let's look at the MFib. Show IP MFib. Summary. Oh, this is cool. Star comma GM, star comma G, star S comma G 1. Show IP MFib. Here's our forwarding, right? Don't know what all these flags are, but there are a lot. And then show IP PIM RP. Yep, uptime expires never. Nice. Not much to that, guys. Once we figured out what the command structure is, it was pretty easy. And let me go back over here to the workbook, and we'll just see how we did. That was a little too easy, to be honest. Yeah, RP address, and on router 5, we tell it that we are the RP address. Yeah, show. Oh, it's interesting. So on router 10, show IP M route. Yeah, so this is how the tree changes, right? So the star comma G now has an RP here, a rendezvous point. And the flags are SJ, join SPT, shortest path tree, C connected, interesting, L is local, S is sparse. Yeah. So we get a lot of information there now on the star comma G's, whereas previously, really the star comma G didn't really mean a whole lot. And if we look at router 5 itself, this is a good thing to look at, right? Try PM route. If we see the RPF neighbor is 0000, right? Because it's us. The RP is us, which means the RPF is us. Incoming interface will be null. And if you look at router 4, show IPM route. This is cool. Yeah, this because we've already started pinging. Once that expires, we'll have no route though to that. Tunnel. So this is the new feature that we didn't have before, right? Show IP PIM tunnel. PIM encapsulation. Source. State is up, last created. Yeah. And then if you try to configure this tunnel, yeah, it's just for registration. Configuration not allowed. But you can do, this is cool, show derived. I've never seen this before. Huh. IP unnumbered, tunnel source, tunnel destination, no routing dynamic. For description PIM register tunnel. Cool. And then a router 5 will have 2, right? Encap and a decap. So the encapsulation is sourced at the loopback interface. And the decap, interesting. Show IP, show derived config interface T0. Wow, that's cool. Wait, is that the right tunnel? Tunnel 1, sorry. What to say? Okay, same thing. All right, so that takes care of the sparse mode. What is our next lab? PIM Sparse Dense mode, which means it's break time for me, folks, because I'm not ready to do that lab yet. But looking forward to it. I'm going to do a little more studying this morning, and we're going to tackle a few videos. I'm going to review some of the stuff that I looked at earlier in more detail in the INE workbook. I just want to thank everybody for stopping in, hanging out, and viewing the stream. Please follow this channel if you enjoy it here on Twitch, and you can get notifications as well when we're going back online. I plan to do some more labs this afternoon and tomorrow as well. So we're going to be hitting multicast pretty hard. So thanks, folks, for joining in, and happy labbing, happy learning. I hope you get all the good bits. And we'll see you later today, if all goes well.